Most of us would agree that discharging the city's sewers directly into a river or stream would be an environmental catastrophe. But most of us don't really know how this would damage the habitat for countless species that call the river home. My name's Elizabeth Succo, and I'm going to share with you how natural and created wetlands can play a critical role in the treatment of wastewater. Understanding that this contaminated water should not just be released back into the environment is just the first step. It is critically important to know how it would be so detrimental to the environment before we can understand how to treat it and the role different ecosystems can play in the reintroduction of wastewater. We will first examine the specific impacts that wastewater can have on the natural environment, and then we will address how to treat this water. Finally, we will examine the wetland ecosystem and its direct role in treating wastewater. Wastewater is contaminated water that is generated from a variety of sources. Wastewater includes sewage, gray water from sinks and tubs, and wastewater generated during the commercial and industrial processes. Contaminated wastewater poses a variety of environmental threats. Among these threats are the disruption of aquatic species reproduction and die-offs of the aquatic life in our freshwater waterways. The reproductive cycles of fish and other aquatic wildlife are disrupted by two major factors of wastewater. The first is the temperatures of wastewater. Even after traditional treatment, wastewater can still pose a threat by rising the water temperatures of the stream or river, making the water unfit for species reproduction. The second threat to the reproduction cycle of aquatic wildlife is due to the presence of endocrine disrupting chemicals found in wastewater. These chemicals are typically found in human birth control pills and animal feeding programs. These chemicals cause defects in reproductive formation in both male and female of many aquatic species. Finally, wastewater typically contains high levels of nutrients such as nitrogen and phosphorus. A sudden release of these nutrients into the waterways can lead to rapid aquatic plant and algae growth. The rapid growth depletes the oxygen levels in the waterway, and as organisms die off, the decomposition leads to further depletion of the oxygen in the water, making the water inhabitable. This process of rapid aquatic plant and algae growth, oxygen depletion, and organism die-off is called eutrophication. Traditional wastewater treatment can be broken down into several phases. Each phase is completed within a large plant with specialized tanks and equipment. The first phase of the treatment process is called the primary treatment. During this phase, the foreign materials such as rocks and toys, etc., are removed from the wastewater before it enters a large vat or storage tank. The solid waste and fats are separated from the water by large filter arms that skim the bottom and the top of the tanks. After the solid wastes and fats are removed, the wastewater moves into the next phase, called the secondary treatment phase. In the secondary treatment phase, microorganisms consume and break down the waste particles in the water. After this process, the microorganisms are separated, and some will be used as soil amendments for local farms, and others will be retained and used again in the treatment process. The third phase is the tertiary treatment phase. During the tertiary treatment phase, excessive nutrients such as nitrogen and phosphorus are removed, and then the water is disinfected with chlorine or other similar disinfectants to remove any remaining microorganisms before it's released back into our natural waterways. Now that we have a basic understanding of what wastewater is and how it is treated, we can take a look at some possible alternatives to the traditional treatment practices. Wetlands are a viable alternative to traditional wastewater treatment plants. There are two different types of wetlands. One type of wetland are those that are found naturally in the environment, and the other, well, those are constructed. While both types of wetlands create a filtration system, constructed wetlands offer the flexibility to expand the filtration process through varying levels of wetland pools. Like the traditional treatment plants, the first step would be to remove foreign materials from the wastewater. The first level or primary treatment in wetland treatment of wastewater would be the process of moving the water through pores in loosely packed soil or gravel. Plants such as reeds and cattails aid in this initial step by keeping the soil or gravel loose to allow the water to filter through. These plants also start the process of removing excessive chemicals and nutrients. Wastewater can move through a series of pools in loosely packed soil or gravel, with each removing more of the contaminants. Naturally occurring microorganisms in the wetland environment act as decomposers of the waste. Plants and microorganisms of the wetland satisfy the secondary and tertiary treatment process. Depending on the needs, some may take the wetland filtration process one additional step by adding disinfectants such as chlorine or other chemicals back into the water before it's released into the natural waterways. Wetland wastewater treatment is ideal for small towns, farms, or industrial plants. Smaller towns and municipalities can reduce the need for traditional wastewater treatment plants. These smaller towns and municipalities would experience financial benefits in that the wastewater treatment plants run approximately 50% to 90% less than the cost of traditional means. Aside from the financial benefits, wetland wastewater treatment also generates new habitat for wildlife and migrating birds. Untreated wastewater poses countless environmental hazards. Wastewater is harmful to the reproduction cycles of many aquatic species due to temperature increases and endocrine disruption chemicals. Excessive nitrogen and phosphorus present in wastewater can also lead to die-offs and the waterways being uninhabitable due to eutrophication. Wastewater treatment is critical to the management of our water quality. Traditional wastewater treatment involves large plants that transition the wastewater through primary, secondary, and tertiary treatment phases. The primary phase is the stage where solid waste and fats are removed from the water. The secondary phase utilizes microorganisms to remove contaminants. Finally, the tertiary phase removes any excessive nutrients from the water. Wetlands, both constructed and natural, reduce the need for traditional wastewater treatment. Wetland wastewater treatment meets treatment standards and is 50 to 90% less costly than traditional practices. Wetland treatment of wastewater is ideal on smaller scales and provides an alternative to small municipalities and creates visually pleasing landscapes that can be home to a diverse community of wildlife and migrating birds.